What if I told you that a cozy little online store could be completely taken over, not with some super complex code, but with just a couple of characters typed into a simple login box? Well, that's exactly the story we're going to dive into today. Let's see how it all goes down.
It sounds kind of like something out of a movie, right? But believe me, this is not fiction. I mean, just think about it for a second. What if a single tiny punctuation mark was the only key an attacker needed to just walk right through your website's front door?
All right, so let's set the scene. Our story starts at a place called Sally's Store. It's this really charming online shop that sells handmade pottery. A small business run with a ton of passion. But just like any online business, it's got a digital front door, a login page. And this is exactly where our two main characters are about to cross paths.
So on one side, you've got Sally. She's the store owner, and all she wants is for her business to run smoothly and, of course, securely. And on the other side, we've got Kim. Kim is an ethical hacker, what we call a penetration tester. Now, Kim's job isn't to cause any trouble. It's actually the opposite. Kim's there to find the weak spots before someone with bad intentions does.
I mean, this login page, it looks familiar to all of us, right? We see these every day. But what's lurking behind this simple little form? Well, it's a MySQL database, and it's holding everything. Customer accounts, order histories, all that personal info. It is a literal treasure trove of data, and it's all supposedly protected by what looks like a standard, everyday username and password check.
Okay, so here's where the action starts. Kim's first move isn't what you might think. It's not some big, loud, brute force attack. Nope, it's way smarter. It's reconnaissance. Kim starts by just poking at the login page, testing how it responds to different inputs, trying to find a little crack in its armor.
And guess what? Kim finds a crack almost immediately. Now, pay close attention here, because this is the key. Look at the difference in how the website responds. When Kim types in a totally random username like admin, the site says, user not found. But when Kim tries something a bit more specific, like Sally_admin, it says wrong password. See that? That tiny difference? Well, that's everything. It's a dead giveaway.
So this vulnerability has a name. It's called username enumeration. What's happening is the website is basically and completely unintentionally leaking information. It's confirming which usernames actually exist in its database. For an attacker like Kim, this is a huge advantage. He doesn't have to guess both the username and a password anymore. Now he can just focus all his energy on finding one valid username.
All right, so Kim's got his first clue, and with that, he puts together a simple 4-step plan. Step 1 and 2, done. He's probed the page and found that critical error message clue. So what's next? He needs to generate a list of likely usernames and then find a tool to automatically test them all for him.
Now, here's what's so clever. Kim doesn't just grab a generic list with a million common usernames. I mean, that's just inefficient, right? It's like looking for a needle in a haystack. Instead, he writes a quick little Python script that's completely tailored to Sally's store. It creates logical combinations using her name and common admin roles. We're talking a much smarter, way more targeted approach.
And that script? It runs in like seconds. The result is a super clean, highly probable list of just 36 potential admin usernames. Think about that. Not thousands, not millions, just 36. This is going to make the next step incredibly fast. So, to automate all this testing, Kim fires up a tool called Hydra. It's perfect for this. He just feeds it his list of 36 usernames, tells it to use any old dummy password for every single attempt, and then gives it one simple instruction. Look for that very specific wrong password response. Basically, if Hydra doesn't see username not found, it's going to flag a potential match. And it only takes a few moments, and then, boom, Hydra gets a hit. The username SallyAdmin is real. It exists. So, phase 1 is complete. Kim has found the key to the lock. Now, all he has to do is turn it. All right, now for the main event. This is what it's all been leading up to, the SQL injection. This is the moment where Kim is going to bypass that password check completely and get full access to the admin dashboard.
And this right here is the crucial point. Okay, he has the username, but trying to guess the password could take forever, right? So Kim asks a totally different question. What if the password doesn't even matter?
Okay, look very closely at the screen. This input right here, this is the entire attack.
He enters the valid username, Sally_admin, and then just 2 extra characters, a single quote and a hash symbol. That's it. The password field, totally irrelevant now.
He hits the login button and, just like that, he's in, full access. He is now logged in as Sally, the administrator, with complete and total control over the store's backend. And all it took were 2 extra characters.
So, what just happened there? I mean, it looks like magic, right? But it's actually a really simple, almost elegant exploitation of how the website talks to its database. Let's pull back the curtain and break it down. This is the perfect way to see the trick in action. Okay, on the left, that's the normal SQL query. The database needs to match a username and a password. Simple enough. But now, look at the injected query on the right. That single quote that Kim added, it closes the username field early. And that hash symbol? In SQL, that means ignore everything after this. It turns the rest of the command, the entire password check, into a comment. Poof! The password check is just gone. The database completely ignores it. And that, my friends, is the definition of SQL injection. It's an attack where you trick the website's backend into running a database command it was never ever supposed to run. In our case, the command was basically, hey, database, find me a user named Sally_admin. And, oh, just ignore the password part. And since that user exists, the database says, yep, got him, and the website just grants access. Simple as that. Now, the scary part about all this is just how common this kind of vulnerability is. But there's good news. The good news is that it's actually incredibly easy to prevent. So let's talk about how Sally can secure her login page and lock that door for good. Really, it comes down to 3 key defenses. First, and this is the big one, use something called prepared statements. They basically separate the SQL command from the user's data, which makes this kind of injection literally impossible. Second, you have to sanitize and validate all user input. The rule is simple: never, ever trust it. And third, use generic error messages. Something like invalid credentials is perfect. Don't ever give attackers clues by confirming whether a username is valid or not. So here's the crucial takeaway from all this. While the consequences are, absolutely severe, we're talking about exposing all of your customer data, the fixes are surprisingly straightforward. This isn't some complex, high-level, movie-style exploit. It's really just a failure to implement basic security hygiene.
And that really leaves us with one final thought. Remember, Kim was one of the good guys, an ethical hacker, but so many attackers out there aren't. This whole story, this story about a single quote and a hash symbol, it should make all of us, whether you're a developer, a business owner, or just a user, ask a really simple question. The next time you look at a login page, is that front door truly locked, or is it just waiting for the right character to come along and swing it wide open?